Coming to nerve injury and generation, we find nerves have a capacity to regenerate till about 50% of the fibers are lost. This 50% is a point of no return. More than 50% are damaged, then it is unlikely the nerve is going to regenerate. When a peripheral nerve is injured, the surrounding non-nerve cells will initiate Wallerian degeneration. We have seen the other cells like the oligodendrocytes, the macroglia which are there around the nerve cells. In this process, there is a degradation of the axon, which if the nerve is injured, there is a degradation of the axon, leads to the fragmentation, and this occurs within the first 1 or 2 days after the injury. As you can see from this slide, the macrophages are recruited to the site of injury and carry away the myelin which is fragmented, and the distal stump degenerates and it becomes small. The non-nerve cell response will promote a environment that supports regeneration, and subsequently the axons can be regenerated over months. When there is Wallerian degeneration, there is point of no return has taken place. So, nerve degeneration sets in and you can have the symptom of pain, there is a symptom of peripheral neuropathy, there is no regeneration. So, let us see the role of vitamins in the nervous system. Vitamin B1 thiamine is associated with many vital functions in the nervous system. We know that thiamine deficiency produces beriberi. Of late, we do not see them as much as we used to see about 30-40 years ago. This beriberi affects the cardiovascular system, can produce a congestive cardiac failure, and also affects peripheral nervous system by producing polyneuritis. It can be a very fatal condition, and thiamine plays a pivotal role and in nerve regeneration in this situation. Thiamine has many different mechanisms of action. It can be a neural signaling effect, antioxidant, acts on the immune system, mitochondrial function as well as energy production, and all these also play a role. Let us see how it helps in nerve regeneration. This he does through mechanisms. 3 mechanisms. One is the cellular energy generation nervous system. Second thing is it stabilizes the cellular membranes, and it also has other effects on the axons. So, let us start off with this thiamine's role in cellular energy generation in the peripheral nervous system. I am not going to the central nervous system. One of the important functions of thiamine is its contribution to the cellular energy metabolism. It acts as an essential cofactor and helps the conversion of carbohydrates, and thus helps providing energy to the nerve cells. The main activity is to enable biochemical steps such as pentose phosphate pathway, glycolysis, Krebs cycle, otherwise citric acid cycle, which we have studied in biochemistry, and through all this it helps in the maintain the integrity of the neurons. Thiamine also directly involved in nerve stimulation because it interferes with the structure and function of the cell membrane, and it participates in the maintenance of myelin sheaths, because of which it contributes to the nerve conduction velocity, and it also helps in the maintenance of the nerve sheaths. Coming to the other effects of thiamine, it is also needed for the energy consuming synthesis of nucleic acids, which are the neurotransmitters and also helpful in myelin. Then the antioxidative properties with sufficient amount of thiamine may prevent cell damage resulting from hyperglycemia. So, in this you can see the citric acid cycle here, the glycolysis, and pentose phosphate pathway. TPP is the thiamine phosphate, and you can see what happens. This is there which incorporates the glycolysis, and through the pentose pathway it is helpful for the formation of nucleic acids, coenzymes, steroids, etc., neurotransmitters, etc. And it also takes part in the glycolysis and in the Krebs citric acid cycle. And here you find that thiamine pyrophosphate, through its mechanism of conversion of acetylcholine to acetyl-CoA to myelin, and to the thiamine pyrophosphate in the citric acid cycle, which again also can act through the acetyl-CoA on myelin, it is helpful for the integrity of myelin. It's very important. So, it acts through the pentose phosphate pathway for the nucleic acids, and through acetyl-choline-CoA pathway for myelin, and through the citric acid cycle for the amino acids, glutamate, GABA, aspartate, etc.